Alright guys, so let's have a look at running through our calculations from from yesterday's practical. This will serve as an example on how to do any titration really where you're using a primary standard, then a secondary standard to work out an unknown solution. So in this case, we're trying to work out the moles of acetic acid in vinegar. So nice and straightforward. The way we could do it though is we didn't do it with a primary standard, we did it with a strong base, which was a secondary standard worked out from potassium hydrogen phthalate. Alright, so let's have a quick look at, so let's work out how to do this. Alright, so the first step is to work out how much of the primary standard you use. This is your known. So we've got one mistake over here already, and that is that this should be 5.00 grams, because that's how specific we are in a titration. So over here, your 5.00 grams divided by, so moles is mass divided by the formula mass, divided by the formula mass of potassium hydrogen phthalate, and it has given you this number here, 0.02448340025 moles. Okay, that's obviously more accurate than you actually know it to be, but we like to only round down at the very, very end. So you can use that to work out the concentration. So we've got the moles of this primary standard dissolved. Now we're going to work out how much, like what the concentration of that primary standard is. And that's nice and simple because you drop it in a volumetric flask, which is over here at 0.250 liters. And that has given you a concentration of 0.097933601, which moles per liter. All right, so then you want to work out the moles of the potassium hydrogen phthalate used in the titration. So we could do this with the formula of C, that should be a C, C equals N over V, which we're actually looking for N in this case, so we rearrange that to N equals C times V. We know what C is, it's this number here, so we'll put a little A there, so it is A times 0.0, because remember we put 25 milliliters into the conical flask, 250 liters. So if we do that, that will give us 250. I'm just doing this on the calculator on screen, which gives us 0.00245 ... moles. Okay, cool. You'll also notice that that is exactly 1/10 of that because we use the tenth of the volume. All right, so nice and straightforward. Now we need to work out the titration ratios, which is one of the potassium hydrogen phthalate. 1 mole of that is to 1 mole of sodium hydroxide. All right, so that's all nice and straightforward, which means the moles of NaOH we would have used to react equal the same thing, which is that it's still at 0.0245 ... moles, and this will allow us to work out the concentration of our secondary standard, and this is really important to us. So what we do is we go concentration equals N over V, and this equals 0.0245 ... divided by, and we take it from our number over here, and that is 0.25, go away Facebook, 0.25, no, that's 0.02536, get out of there. So we do that calculation very quickly, 0.02536, that's our volume, and that brings us to a concentration of 0.09654 moles per liter. All right, we've now standardized our sodium hydroxide. Yay, go team us. So when doing this, we basically now just start at about this step here again, okay? This is where we start again and do the same thing over. So let's clear us off a little bit of space here, and we're going to go down a bit further. That'll do. So the moles used, now remember, we used a standard 25 milliliters of, so we want to work out how much of it, the moles of our standard, basically. So there's moles of potassium hydroxide, or sodium hydroxide equals concentration times V. So it is, in this case, 0.09654 times 0.0250. Okay, and we now add this together, or sorry, multiply this together. So I keep losing my mouse. We times that by 0.025, which gives us a moles of 0.00241 ... All right. So that's nice and simple. That makes perfect sense. It's not like the numbers look like they all match up. We now need to work out how many moles of acetic acid is in this reaction. Now, luckily for us, the moles of acetic acid is a 1-to-1 ratio. So now we work out the moles of acetic acid, which equals the moles of sodium hydroxide, because it's a 1-to-1 relationship. So moles of acetic acid is the same 0.00241 ... Okay, so that's how many moles we have of acetic acid. Then, and this is the second last step, we want to work out the concentration of acetic acid. So concentration becomes moles over volume. Here is our volume up here. And so we take our moles from the calculation above, 0.0241 ... Now in my calculator I've not gotten rid of that at all. And we divide it by the volume, which is 17.92, to use the average. So 17.92 milliliters, which is 0.01792. So we do that calculation now. And that gives us a concentration of 0.135 moles per liter to 3 significant figures. Now that's how you do it. Except our calculation, we have one more step, and that is we diluted this down. We diluted this to a 1 to 10 dilution, so it is 10% as strong, which means our actual concentration is this number here times 10. So we go to that, and it becomes, find the mouse again, so I'll start down here, equals 1.35 moles per liter minus 1, 3 significant figures. That's our concentration of acetic acid. Remember, we diluted it from 100 ml volumetric flask, we put 10 milliliters. So it's a 10 to 1. Now, remember, no answer is complete without our sentence. So you say, therefore, the concentration of acetic acid in, sorry, excuse the sloppy writing, I'm using the, in vinegar is 1.35 moles per liter to 3 significant figures. That's it. That's the calculations. That was them being stepped out. The more you practice, the quicker they'll get. I hope that made sense. If it doesn't, feel free to ask any questions in the comments or shoot me an email and we'll help you out as quick as we can. All right, I hope that helped. Thanks very much. Bye now.